Well, specifically on mine planning and design, we probably have two things. If I look at the mine planning, what we've taken and learned from other industries is that it's not enough just to do modeling. And so we're really looking at combining modeling and simulation together. So when you're running a mine plan, traditionally over the years, you do one, maybe two, and then you kind of stick with that plan and make it work. And yeah, you may have a few opportunities to refresh that, but I don't think that's enough now. And there's a lot of sensitivities in projects, a lot of variables, a lot of things that can really derail you. So our approach on this is really to enhance our scheduling engine, our optimization engines, which really, improves the value of a project, but can consider things like sustainability. And then over top of that, we put simulation. So we work in a kind of design of experiments approach where we look at all of the sensitivities in a project. It could be geoscience risks. It could be the resource model itself. It could be commodity price. It could be, any sustainability factors. How do we actually tweak all of those or give a range of values? And with compute power on the cloud, we can, build like 1,000 scenarios, hundreds of thousands of scenarios, and just run it off, right? So what would have either not been possible, too complex a problem, or would have taken, weeks, months to run. Now with cloud compute and so on, you can, plug it in overnight, come back next day, and you've got 1,000 scenarios. And we've got tools then that can help you pick the 3, 4, 5 that are going to allow you to make better decisions or more robust decisions. So now you have 5 very good plans.
Right.
But you've run 1,000 to get to those 5.
Right.
And then you've got a bit of flexibility in where you go.
It's those digital twin simulations, right?
Yeah, and that just wasn't really, possible even a few years back. And that's been a real leap forward. And we've got a lot of bricks in our stable to be able to deal with that. And then I think the second one is really around the planning and design process together. So mining engineers, mine designers today, if you do find something that goes wrong, you've got an area you can't mine, or you've got to do a reevaluation because you've got a new resource model, that can be a real manual process to go and regenerate your mine design from scratch. That can take a number of engineers, weeks. And everyone's time poor, right? Everyone's in a high pressure environment. Right. So how do we take a lot of those manual automated tasks out of mining engineers' lives so they can spend time more evaluating those designs, validating them, or just spending more time in the field? So we have 2 concepts for this. One is parametric design to start with, and the second one is really about associativity. So by parameterizing everything, we're giving meaning, but we're capturing the knowledge and know-how of the engineer. So we're capturing all of their inputs, their thinking when they were designing, so that when you got this change or whatever, all of that's already taken care of. You can just regenerate it using the same data or the same inputs. And, if people leave your company or they move on, which happens a lot, you're capturing some of that or retaining a lot of that knowledge for the new engineers that come in. And then the associativity is how do you link that plan to the design? So if, for example, we've designed some pit shells, we're happy that we've got an optimized outline of what it could be, but then that changes. Well, now the whole shape of this thing's changed, so now I've got to go and do the redesign again. So what we do is we connect that design to the plan, we connect the ramp to the design, and so on. And so once you make one of these changes, the system knows it, understands it, trigger, and the user can go and say, all right, I'm going to go and trigger this update, and it'll automatically generate it. So then there's still some user input to do some tweaks or so on, but they're only doing tweaks. They're not completely designing from scratch.
Yeah, because I mean, relatively, you could be one drill program away from a total redesign, right?
And it happens a lot,
Yeah.
And that's a big shift. That's weeks of work for multiple engineers down to a day,
right?
Or even hours in some cases, right? And that's a huge shift.